Right, okay, so here I'm trying to explain to you a slightly different method um, of the same question we did in the last video. The M2 question from question 5C, question 6 from 5C. So I'm just going to do the question again with a slightly different method. Again, a geometrical method, and also this method somebody might find a bit easier, because if somebody is not familiar with C3 or forgotten some of the C3 stuff, this method I'm going to explain to you now, you might find somewhat more conducive for your work, or if not easy to think what to do with. Okay, so let me try to get into that. So I'm just going to redraw the question. It's question 6 from M2 book, basically this book. I'm just reminding you again, this is the question you sent me from this book, page 141, 5C, question 6. So that question basically says, they talks about a uniform rod, isn't it? They talk about a uniform rod like this. Uniform rod, they're saying this rod is actually being hanged or kept in an equilibrium. This rod is being kept in an equilibrium using two strings. Two strings called X and Y attached like this. So these are two strings here. So these strings obviously produce T1 and T2 tensions, like we mentioned in the previous video. If you want, you can have a look at the previous video anytime and just compare these two methods. It might be helpful. So right, and also it says this 6G is the weight of the object, weight of the rod. Because the rod is uniform, we can say the lengths are exactly equal. The lengths are this length and this length is exactly equal, and this given as X and this given as Y. And in the question they say the angle is made, this T1, this string makes with the vertical that is given in the question as 35 degrees. So they say basically this is 35 degrees. This is 35 degrees. Okay, and also they mention in the part, as a part of the question, they mention this angle here is 10 degrees. Okay, so which makes with the horizontal is 10 degrees, and that angle is 35 degrees. Okay, that's been clamped here basically, fixed to a point in the ceiling. So the question asking basically, the question was asking, they're asking like two questions or two or three questions, I can't remember. They're asking, one of the main questions are the angle this string makes with the vertical, this theta. They want us to find this. Okay, so we have is a method using sine rule. We got the answer using sine rule, I know that. It seems to be somewhat long, because some of them actually said it's somewhat long. So there are some other methods as well we can look into probably. So let me explain to you such a method. It's still based on geometry. Probably you might like this method. Okay. Right. So what we're going to do is this. Let me redraw this triangle again in somewhat more useful manner. Let me draw it here. So this is the XY. I'm going to draw it like this. Okay. Before I'm going to draw it, let me use this for certain stuff. That is 10 degrees, then this must be 10 degrees as well, because that the Z angles. Okay, they're parallel, the two horizontal lines. That's 35, and this must be 55, isn't it? Because 90 degrees the whole thing. Okay, now let's say this is alpha for the time being, because if we know alpha, then we can find theta, because alpha plus 10 take away from 90, you're going to get theta. So I just put alpha there. And as we know, these are three forces acting on each other, acting on this object. These forces must be meeting there, according to Lami's theorem. So the forces are actually meeting there, because these are two forces going like that and the other force coming like that. So they must be meeting at a point. What we're saying here, actually three forces in balance, isn't it? So these are three forces. That's T1, that's T2, and again 6G coming down like this. See, if we extend that, it goes like that. So we can clearly see according to Lami's theorem, there are three forces. They're coplanar in the same plane and also concentric. They are all moving towards each other. So they are so fine. Or either they can actually move away from each other, that's also fine. Either way, in this case they are moving towards each other. Concentric. Alright then. So that's alpha. So let me draw this. Actually, what else we can get into? That's 55, that's 10 degrees. And then we know that's 90 there. So we can see that is basically that is 55, that's 90, that's 35. Or you can think like that's 35. And that's 10 degrees, that's 10 degrees. And that'll be 8 degrees. Because that's 90, that's 80. Okay, so that's all we have. So let me draw these things as a triangle. Like that, that's basically alpha. Okay, that's in the middle. That's in the middle like that. That's not 90 degrees. Okay, that just, these two lengths are equal. This is the midpoint there. Let's say that's E or something. So that's in E. This angle, Y angle there, it is 65 altogether, right? So that's all, that should be 65 degrees as well. And this angle we say is alpha. Okay, so that's alpha, that's fine. And what else we know? We also know that's 35. So I can say that's 35 degrees. Is OE, isn't it? And also I know that's 80. Okay, right. So the whole purpose, our goal is to basically find out, alpha. We try to work out the value of alpha. If you can't find alpha, then we can find theta easily. Because why we know these two angles, then we can take it from 90 degrees, we're going to get theta, like we mentioned. To do that, before, like we mentioned it before, basically, we used sine rule for this triangle, and we did some work and we got the answer. Now in this method, we are using a slightly different method. In here, I'm going to draw I'm going to create a small perpendicular line like that. Let's say that's F. Okay. Let's assume this length is H. From there, OF equals to the length of OH basically equal to H. OF. Right? And we know XC and XEY are equal because that's the midpoint of the rod. So let's say XC, the length of XC is A. Okay? Length of EF is X or something, X. And that become then A minus X, isn't it? Right? Because well, that's X plus A minus X become A. That's the midpoint because of that. Cool? Now what we can do, now there are a few triangles here. There, this triangle, and this triangle. They all are 90 degrees. They all are right angle triangles actually. Because this triangle is a right angle triangle. This little one is a right angle triangle. And this also right angle triangle. There are three right angle triangles. Let me write. There are three right angle triangles. One is OFY, is right angle. It's a right angle triangle. OFE is a right angle triangle. And OEX is a right angle triangle. OFX. OFX. They all are right angle triangles. Right angled. Okay, does it make sense, Steve? They all are right angle triangles. because that's 90 degrees, so that's a right angle. And the big one, XFO is a right angle, and this is also a right angle. Cool? Okay, so now we can do something interesting. So we can write some equations. We can just use general trigonometry, sine, cosine, tan, or whatever useful. Let's look into OFY first, that triangle. For OFY, we can say triangle OFY, basically. We can use tan, isn't it? Tan 65 equals to h over a minus x. H divided by a minus x. Okay. Tan 65. And also we can write, that's all actually we can write for this triangle. And also we can use the other triangle, OEF, triangle OEF. We can say tan 80 equals tan 80. Let me write small, those slightly big, too big, right? Tan 80 can be written as so tan 80 can be written as that's the opposite, that's the adjacent, HOX. So HOX. And also I can use that XFO triangle. Tan alpha equals H over A plus X. H over A plus X. Cool. Now we have three equations. We can solve them simultaneously. We have three equations, equation 1, equation 2, and equation 3. Okay, so now we can probably solve them simultaneously. To make this very easier, what I'm going to do, I'm going to write in cot. You will see why I'm going to do the reason I'm doing it, you will see in a minute. I'll write in cot. So I'm going to get cot 65 equals to A minus X divided by H, which means A over H minus X over H, isn't it? Because I can see that H is the common denominator, so I can separate it. And also 1 over tan, because if I flip it, I'm going to get a 1 over tan. 1 over tan means cot, basically. So I haven't done anything different here. Basically, I've written the reciprocal of these functions. That becomes cot 80. Cot 80 become X over H. So nothing, no changes there. The other way around, that's become cot alpha equals A plus X divided by H, which means A over H plus X over H. Okay, A over H plus X over H. Does that make sense? Right? I hope it does. Now what we can do, now can we eliminate, now we have three equations, three unknowns. See, we have alpha is an unknown. Three equations. We have few unknowns. We don't know H, X, and alpha, and A. The good thing about it is actually we can remove certain things and we can get a value for alpha. That's our plan. See whether we can do that. So it's a special, very interesting case. We can probably find tan alpha using this, or alpha basically. Now let's say I'm going to add these two equations. These two equations, I can add them together. Then I can eliminate. If I add them together, what I'm going to get, let me do it here. Cot 65 plus cot 80 basically equals to, so when I add them together, what I'm going to get, they cancelling out, A over H, A over H, because the X minus H and X minus H cancelling out. And also, if I take away from each other, if I add these two together, okay, cot alpha plus cot 65, cot alpha plus cot 65, I'm going to get cot alpha plus cot 65, I'm going to add them together, I'm going to get 2a over h. 2a over h. Cool, there you go. I think we can see the light now. Now I can times the top one by 2. I'm going to get 2 times cot 65 plus cot 80 equals to 2a over h. Okay. Basically that's, let's say that's equation 3, that's equation 4. So this one is gained by times in third one by 2 basically. 3 by 2, okay? So now I can equate this 2. So let's assume that's 3 dash. Now I can clearly see the right hand sides are equal here. Then I can equal the left hand sides. So I can say then cot alpha plus cot 65 equals 2 times cot alpha plus cot 80. Okay? So this is going to yield, we can simplify this actually. We're going to get cot alpha plus cot 65 equals 2 cot alpha plus 2 cot 80. So we can take away from each other. I'm going to get cot alpha equals to, move this side and move this on this side. I'm going to get cot 65. And these are simple stuff. You guys should be able to do it these. Especially when you are doing C4 and M2. So alpha can be gained using cot inverse of this. Cot 65 minus 2 cot 80. If you do this, well, if you can't find cot 65, you can open a calculator, which you can find tan 65 because you can sub 1 over tan 65 and 2 times 1 over tan 80. You should get the same answer. So you will actually get for this one around 50 degrees. 50 degrees alpha is equal to around 50 degrees. So 50 means this alpha is 50. So it'll be around 51 to be honest. 50, 51, let's say 51 for the time being. You know, I'm not going to waste time just using a calculator here. Around 51 degrees you're going to get. So this will become 51, so that's 51 degrees. So 51 plus 1 becomes 61, then that's become around 29 degrees. It's like we got in the previous question. So theta can be found as around 29 degrees. So if you do properly, use a calculator, you will actually get the previous answer, 29 point, I think it was 31 or something. If I can remember, it was 3, that's something sort of big, so answer 29.31. So I have this slightly different method. I don't know, maybe somebody might find this is longer than the other one. They're all the same. This is a bit like GCSE stuff in a sense because we use this tan much more simpler manner. So yeah, so this still remains a geometrical method rather than going into the Newtonian resolving forces. So nothing wrong with that either, like we mentioned before. But I think this is also another strong method. So yeah. Alright then, I think that's cool. Okay.